your favorite time again, right? That mental break time. I just remind you that, you see, if you were in the class, I will allow you a physical break. Go out, walk around, take some sips of water and so on. But in video lectures, of course, you can take a physical break anytime you like. So this is a mental break. Now this is a slightly mature joke, right? Higher class. We won't generally tell this type of a joke in a lower class, most probably. And this is very much relevant to what is happening in the world today. So now a person goes to a fashionable dress and shoes shop, right? They are a well-known brand and so on. They sell dresses and those things also. They sell shoes also. You go to the shoes and you are looking at shoes and so on. Now a salesman comes, can I help you? You ask him to help and so on. So yes, now he, the shoes that you have selected, he takes your shoe size, he lets you sit on the sofa where you sit in a shoe shop, and then he carefully sprays on your feet, he carefully sprays the sanitation liquid and so on, the sanitizer, sorry, and then after that he sprays with water and he takes a towel and carefully wipes both of your feet and so on, and then he tries on the shoes and so on. The size is also very good and you like the design, so you say, okay, this is very nice, pack them for me and so on. So once he is doing the packing and so on, he says that, would you like to buy some other things? We have a very good shop here and so forth. So now you tell him that, you see, I also wanted to buy some boxers underwear, but the great treatment that you have given for my feet, I will not buy the underwear today, please. Back here, the joke is over, right? So you have solved the problem in detail. You start going back, right? If you want to find the force, you should know the pressure. So this is the general pressure equation, whether it is hot or cold. But because it is hot extrusion and poor lubrication, so this is your equation. From this equation, you put the value of the strain rate into the flow stress equation, right? And from the flow stress, you go back to the pressure, and after finding the pressure, you multiply it by the area to find the force. And let me repeat myself that even though we do any one or two good problems, but if they are good detailed problems and your brain is open, right, the bulb is on, and you are seriously reading the problem, taking down the known data, the unknown data, you go back and see what equations are available. If it is in your home and so on, you go back always to chapter 2 and find out the material parameters. If it is a quiz or an exam, then with the formula sheet, the tables will be given to you. But you have that habit and you think of the mechanics of the problem, of the physics of the problem, you think back and forth, and then before you start, you make steps that I need force, so I need pressure. I need pressure, so I need flow stress. I need flow stress, this is the equation. In this equation, I have to find a strain rate, so this is the equation, right? So you connect mentally and then you go ahead. Now some general topics about extrusion. The mechanics part, the numerical solution part is mostly over. Miscellaneous extrusion processes. So cold extrusion, right? Hot extrusion we have done. A combination of processes, particularly extrusion combined with forging, cold extrusion, right, are there in miscellaneous. Now cold extrusion has advantages such as improved mechanical properties. Now I always have a problem. I always have a problem when they use this type of thing. This is conditional. I have told you in forging and rolling also, it is conditional. Some properties will be better in cold working, some will be better in hot working. When you say improved mechanical properties, I don't totally agree. Right? Now what will happen in cold extrusion, because if a cold work is done, then strain hardening is happening. Yes, strain hardening is happening. Therefore, strength and hardness related properties will improve. But if there is cold extrusion, friction will be a big issue. So friction related problems can happen, right? So this improved mechanical properties, you should always think in your mind that this is a conditional statement. Good control of dimensional tolerances. Good control of dimensional tolerances. This is again conditional. You see, if the cold extrusion process is going very well, the friction is not out of control, the extrusion speed is not too high, then problems like cracking and so on at the surface will not happen. So dimensional tolerances will be good, surface finish will be good. But if you don't control the lubrication very well, the surface finish very well, the extrusion speed very well, then in cold there can be problems. Compared to hot, in hot there is an issue that oxidation can happen. So new alloys or new materials can form on the surface and there will be issues, right? So whenever they say dimensional tolerances and surface finish, then sometimes they will be better in cold work, sometimes we can control them better in hot work. But of course, in hot work, one problem that always happens in extrusion, when they are extruded out, they are under hot condition. So the material is very soft. So on the roll out table, you have to have very quick cooling with high fans and so on. And once they are cooled down, then you have to go to age hardening furnaces. So in cold, you don't have to do that, right? So that is one thing. High production rates and low cost in cold extrusion. Do you agree? You see, if extrusion is happening as hot work, then you can have very easy high speed, right? Because you don't have to reduce the speed in cold extrusion, you have to reduce the speed of the ram so that there is not too much of extra pressures and so on. In hot extrusion, you can do it faster. The material is softer. So high production rate, how is it possible? You should think. Low cost. Now the thing is that think overall. If it is cold extrusion, you don't have billet heating ovens. You don't have to have high temperatures inside the extrusion chamber, and you don't have ovens or furnaces for heating the dies. So the overall cost of the plant has gone down, right, in cold extrusion. Second, in hot extrusion, the material that comes out is very soft, right? So you have all that furnace, multiple cooling fans and so on system. So that cost goes down. And you don't have to take the material because after this annealing, it is very soft. So you have to take it to big furnaces for age hardening. So all that you remove, right? Furnaces for billet, heating system for extrusion chamber, furnaces for dies, you remove them. All the fan system to cool the extruded hot, you remove. And the age hardening furnaces you remove, right? So therefore low cost, yes. And it is easy to do now. But why are production rates better even though extrusion speed will be higher in hot extrusion, not in cold? But then you don't have to do the cooling system, you don't have to do the age hardening system and so on. So overall the production rate is good even though directly during extrusion, only extrusion chamber, cold extrusion is slow, hot extrusion is fast. But after extrusion is completed, in cold extrusion, you have the direct product almost. In hot extrusion, you have to have the cooling fans and you have to have the age hardening. So therefore, right, so if you think, you know these facts, but if you think, then you can say why production rates are high in cold extrusion and why overall cost is low in cold extrusion. Here, two examples of cold extrusion, right? this is direct, right? Force here, extrusion here. This is indirect, force here, extrusion going back, right? So this is forward or direct extrusion, this is backward extrusion, right? But both can be done in cold, right? Cold, right? So they are saying that these parts may also be considered as forgings, right? Here, if you are not allowing the material to flow through, if you are just reducing the shape, just reducing the height, here you are punching here and it is going back, like in impact extrusion. So they are like, right? So if you do it one piece at a time, even though you are using the extrusion press, first of all, if it is in this vertical condition, then remember when we did classification, it is vertical extrusion, not horizontal extrusion, right? Impact extrusion is where you make cans and so on. So it depends whether you are doing it in hot or. Now extrusion pressure for different extrusion types, this is very different extrusion types. So once again, the vertical axis is maximum extrusion pressure. Remember, the extrusion pressure goes up, then goes down a little and so on. So we are interested in only the maximum value of the extrusion pressure. So on the left, you have psi into 10 raised to 4. So 10,000 psi. On the right, megapascal. Extrusion ratio here and true strain there. So this is a very good thing that you have maximum extrusion pressure either in 10,000 psi units or megapascal unit, but pressure against extrusion ratio or pressure against true strain, both are given. And now A, B, C, D, different types of extrusion. A is direct extrusion with 90-degree angle, flat dies. B is hydrostatic extrusion, where lubricant is inside the chamber with die cone angle of 45 degrees. C is hydrostatic extrusion when the die angle cone angle is 2.5 degrees. And D is only ideal homogeneous deformation, not the total work. So this is brilliant that you have the equations and you have plotted the maximum extrusion pressure based on each of these. So if you see, of course, D is the lowest curve because it is only the ideal value. Remember, there is the ideal value, there is the work done against friction and so on. It was in 3 parts. So if you are doing only one of them, then this is not the total extrusion force or pressure. But then if you do C is hydrostatic, pressure will be low. But in hydrostatic, if the die angle is 90 degrees, it is hitting and then coming back. If the die angle is 22, then it is more smoothly flowing. So if it is more smoothly flowing, the pressure is lower. But if it is direct hitting 90-degree dies, then even in hydrostatic, it will be higher. So this is lower hydrostatic, this is higher hydrostatic. And then this is general direct extrusion total pressure. So this, of course, is the highest curve. So these type of charts, graphs, if they are given, then rather than calculating from pressures and so on, you just give me the extrusion ratio and I will show you the pressure. You just give me the true strain value and I will give you the pressure and so on, right? So these are very nice sources. Now, generally I leave this for you, right? In rolling and in forging, the defects area. This time I am doing it with you. This time I am going to do the defects with you. There are 2 reasons. One is a sort of my favorite topic, right? In practical engineering over the last 15-20 years, extrusion has been one of my pet areas of work. I have gone to the industry a lot. So therefore, in defects about extrusion, I tell you a little bit more and so on. The second is that, okay, one example that generally I am leaving this for you to study, but at least for one of the manufacturing processes, I am doing the defects in detail with you. So we will continue it, inshallah. For today, I will stop here. Please go through the lecture carefully. See you next time. Ma'as salama.